In this video, I want to take a look at doing a two-sample test where we're going to use a t-test to compare the means of our two samples. Right, so again, the focus of this video really is using StatCrunch, but I want to take a look at the concept of how we would do this by hand. So within this example problem, we see that we're told a local bank claims that the waiting time for its customers is lower than its competitor. The competitor bank checks the waiting times for a sample of both banks, assuming it is known that the populations are normally distributed. Test the local bank's claim, assuming that the variances of each sample are not equal. Okay, so again, why are these two samples independent? We're basically assuming that the customers in the local bank are different than the customers in the competitor bank. They're not related, they don't know each other, they're not the same. So we have independent samples here. So why would we use a t-test? So again, there's basically two conditions that we look for here. Do we know the population standard deviation sigma? In this scenario, we don't. Right? The summary statistics given to us are the sample standard deviations. And then technically what we would need to look for if we wanted to use a z-test was are our samples large enough? So are the samples greater than or equal to 30 within the textbook I use? And they're not. So I'm going to use a t-test. In this case, one other condition that we would need to determine is how we're going to deal with the standard error when we calculate the standardized test statistic. So we have two options. One is if we're told variances are not equal, we do what we would call we're not pooling the standard error. And we have a different formula for that scenario. We'll see in a second. And then if the variances are equal to each other, then we would pool the standard error. And then again, we would have a different formula there. So the textbook I'm using, it tells me that the degrees of freedom when variances are not equal is we're going to take the smaller of the two samples. So in this case, this degree of freedom of sample 1 is 14. The degree of freedom of sample 2 is 15. So we would take the smaller. If the variances are equal, what we do is we add the two sample sizes and subtract 2. So we would do 16 plus 15 minus 2. Now we will not be doing this approach. Right? We will not be pulling the standard error. We will be using this approach. All right, so back to the problem. So the claim in the problem is that the local bank's wait times are lower than the competitors. So the way this is structured, here's local bank, here's competitor bank. So we're looking at the mean of the local bank being less than the competitor bank. So we have mean of sample 1 less than mean of sample 2. Excuse me, these are population means that we're going to be making inferences on based on our samples. So because there's no equality here, that goes into the alternative. There's my claim. And then the greater than or equal to is the null statement. So this gives us a left tail test, and we want our level of significance all in the left tail. So the next step would be to determine the critical value. Right? So again, visually, if I'm doing the rejection region approach, I need this critical value to see if I fall in the rejection region or not. Again, this is already a completed problem, so ignore this negative 0.89 for the moment. Right? So here's my critical value that I would find. Now, again, as I've mentioned in other videos, if I'm using the standard, if I'm using the t-table, here's my t-table. And we have to know our degrees of freedom, and we have a one tail of 0.05. So again, because we're not pulling the standard error, the degrees of freedom is the smaller of the two samples. So here's a degrees of freedom of 15, sample size is 15, degrees of freedom is 14. So looking at our table, one tail, alpha 0.05, we come down to 14 degrees of freedom, and we see 1.761 as the critical value. Now again, this is left tail, so we're going to look at negative 1.761 as our critical value. So there's our critical value. So then the next part of the process here, if I was doing, let me stop for a second. So if I'm using StatCrunch to find this critical value, right, how would I do that? So if I'm using StatCrunch, because I'm doing a t-statistic, I go to stat, I go to calculator, and I call out the t-calculator. In this case, I'm going to choose standard because I want a left tail, and I'm looking for this critical value. Let me delete that. My degrees of freedom was 14, and I want 0.05 in the left tail. So I'm going to click compute, and we can see there's our negative 1.76 that we had from the table. Now, the next thing we'd want to do then is calculate the standardized test statistic. And again, if we're doing this by hand, right, here's our formula by hand. Now, we would subtract the two sample means from each other to find out their difference, and here's me plugging in those values. And then again, because we are not pulling, then there is a particular formula for the standard error. And if you look in your textbook, right, here's the formula we would see. So we would in essence take the variance of sample 1, divide by its sample size, the variance of sample 2, divide by its sample size. And here's me plugging all of this information in, let me scroll back up, based on the summary statistics given here. So doing this by hand and a calculator, I get negative 0.89. Now if I'm, so again, just to finish off our reasoning, I plot that standardized test statistic. I do not fall in the rejection region. So we fail to reject the null, and we interpret that based on the claim. So how do we do this in StatCrunch to finish this problem? Right now we talked about finding the critical value here, but let's go ahead then and perform the actual test. So because I'm doing a t-test, I'm choosing t-stat. In this case, I have two samples, and I have the summary stats. So I'd plug in my information for sample 1, for sample 2, and choose the proper hypothesis. Let me pause and fill that in. All right, so I've filled in that information. The next thing it asks is, do we want to pull the variances? So again, just a quick reminder. In this case, the variances were not equal, so we're not pulling. So in our in a StatCrunch, we would pull if we were doing that. In this case, we are not. And then our alternative was a less than. So we had a left tail test, so I'm going to choose the less than. I like the graph, and then I compute. So I get 2 pages of info here, right? Here's my standardized test statistic of negative 0.89, which is what we got on our problem, negative 0.89. And then if I go to the graph, right, here's me plotting the negative 0.89. Now, as I've talked about in prior videos, what StatCrunch does not do in this piece is give me the critical value. So that's why we had to find that separately. But it does tell me the p-value, right? So if using the p-value approach, this p-value is not less than 0.05. So we would fail to reject the null. So again, same conclusion, whether we're using the rejection region or the p-value approach. So that is how you would do an independent sample, right, 2-sample t-test.